Hi, I'm Clark on Temptress. Today on the Boat Electrical series, we're going to talk about how to end wires, how to connect them to each other, terminals. When you're on a boat, you always have to think about corrosion. It's going to happen, so minimize it. And you also have to think about physical restraint, because when things get away in a moving, bouncing environment, anything can happen and you don't want a live wire throwing around. Today we're talking about types of terminals and other tools and supplies you need to connect wires in ways that are safe and secure, that minimize corrosion and lower the resistance. Earlier episode of the Boat Electrical series, I've talked about wire, and we now know all about wire and resistance. Well, wires have to be connected to things. They have to be connected to each other or appliances, and that's done with some kind of a terminal. Today we're going to talk about terminals. They're very important. It's a very important topic. They're exposed to the environment. Corrosion can build up very easily on them, and that corrosion can cause resistance. Remember, my big theme in this whole series is resistance is our enemy. And eventually we're going to go into how to find bad resistance. But right now, let's talk about how to keep it from happening, because there's no better way to solve a problem than not having the problem start. So we're going to need to connect wires together. We have a wire, strip back the insulation, and we need a way to make this wire, let's say, connect to another wire. Let's look at the options. So you've got your wire and you want to connect it to something. Let's look at some of the options. Oop. Our probably biggest friend everybody has used is the Crimp Connector. And I'm just going to show you the Crimp Connector right away here. It comes in all different styles. This one is for connecting two wires together, but there's other ones. This one, for example, is for connecting to some kind of a ring terminal. For example, this, but we'll get to that in a minute. And there's things like this, kind of a personal favorite of mine. It's called a bullet connector. You can hook a wire to each of these connectors and pull it apart, and you get this way of connecting things that honestly seems a little more robust than other options, and I've been enjoying it of late. Now you can see that these, when you buy a kit anyway, they're in three colors. Red is for itty bitty wire, blue is for middle-sized wire, like up to 14 gauge, and yellow is for the larger wire, 12 and 10 gauge. It's important you use the right color with the wire, because you won't get it to crimp on there properly if you use the wrong one. So we have crimp connectors. Now let's talk about the tools that we would use. Really, you need two. You need a wire stripper, and I've tried everything, and I've tried the fancy ones that kind of do it all for you and you just squeeze them. Honestly, I'm liking these the best. They just grab around the wire. In fact, let me cut off a piece. They grab around the wire, you set it for the appropriate gauge, they cut the insulation without cutting the copper, and then you just pull it off. Sometimes simple is better. Another tool is some way to squeeze the crimp connector, and these cost a little more than the simple ones you get at the auto parts store, but I've come to feel that this style is well worth it, and it's all I use now. All these tools and most everything I mentioned here, I put a link to it in our Amazon store. Buy it anywhere you want, but if you see it there, you can kind of look through it and get a better idea of what the tool or the device is. I am taking my best shot to choose the best items I find for sale on the day that I do the looking. Not necessarily stuff I've used before, but it looks like what I would buy if I were to buy it that day. Best I can do. Okay, let's talk about the crimp connector. This one is kind of the Cadillac one. It has a tinned copper tube in the center, and it has little stops on it, so you can't push the wire in too far. And you push the wire well inside the copper crimp area, and then you just crimp it. To do that, you open your tool, get a little rusty with age. You find the side that has the colored dots. There's a slot for the red, a slot for the blue, and a slot for the yellow, just like the connectors come. You put it into that slot, and in the case of a butt connector, being very careful that it only does one side of the crimp, because you have to put the other wire over here. And what I found over the years, make sure the dot, at least on my tool, the dot is on the wire side, where the wire comes out. Then you squeeze it down all the way. It won't even release until you go all the way. And then it will pop open, and you've made the crimp. And they check them. Make sure they're good. Make sure they're good and tight. Now this one is the Cadillac style, I called it, because of one thing. Well, actually, let's put the other wire in first so we can do it all at once. So I'm stripping some more wire, and I'll shove it in there. Make sure it goes into the copper. And I'll crimp that side. And give it a test. It's good. In this one, the plastic parts aren't just there to kind of shield from touching. They're actually a shrinking plastic with some glue inside. So if I heat these up, they'll shrink down on the wires, glue themselves to the wires, and make this quite waterproof. You can do this probably most easy with an electric heat gun, but I don't like to pull out cords. So I've got my handy dandy portable soldering iron, hot knife, butane powered device here. And it has a little blowtorch attachment. So I'm just going to add some heat and make these shrink. This thing is a great soldering iron and hot knife, but as a torch it's kind of slow. We got a few seconds. Okay, it's starting to shrink down and the glue is melting. And one more little bit here. Okay. I would do both sides, but you can see that shrunk down and there's some glue in there, and that's a waterproof connection now. That's a good way of making a contact. Another way I found to connect wires, only lately, so I don't have a lot of long-term experience with them, but I got to tell you, I absolutely love them, are these little spring things. You can open up the door and you can twist your wire and shove it in there. You just shove it in the hole and clamp down the spring. And it bites into the wire, and it's a pretty good contact. It's really great because if you want to break the connection, you can. And if you want to make it again, these are very reusable. On the downside, I'm not convinced that they'll pass as much current, so I use them for like LED lights and things like that. I don't think I would use them for, I don't know, something that really had to draw like 15 amps or something. And I'm not convinced they're going to hold up to corrosion because they are pretty exposed and they have mechanism. So I wouldn't use one in the bilge at all. I would use the shrink approach that can be completely waterproof. There is a trick I'll get to in a minute that will work with these that will let you use them in keep the corrosion down a little bit more. Just to kind of finish up on these things, if you get this style, they lock together so you can have a gang of them for parallels. And then there are some I have with 3 and 5 connections. And this is really handy when you have 3 wires that need to come together. Doing these with terminals kind of needs all kinds of expensive parts. These let you reuse it, connect, disconnect, and very easily make little gangs of wire that come together. So they're surprisingly inexpensive, and I'm going to be using them until I find that they don't work for me, but I'm thinking high hopes on those. Let's look at some more of the things that are available here as terminals. We have the Spade connectors. These are shielded, so it's a little hard for you to see them, but you've probably seen them before. It's just a little 1/4-inch shovel looking thing and a female end that locks into it. Again, this is good for wires that you might have to remove later. But, oops, it came apart on me. But honestly, I'm preferring the bullet connectors for that. Where I use those quick releases are things like bilge pumps or the boat's water pump. You might have to pull the water pump out a few times during its life and clean its valves and get it working again. Maybe adjust or replace its shutoff valve. Anyway, things that you need to pull out and do some work on, it's way better to not lock them into the wiring system. Put them in a way that can be removed. Another way you can remove things is to use ring terminals. You use these with these blocks, these bus bars, lots of name for them. They come as large ones, and this isn't all that particularly large. I use 3/8 inch studs a lot on Temptors for the big battery wires. And they come in small ones. These are really handy when you have things that need to be hooked and disconnected in an area. For example, I have one of these in my bilge above the water line, and I expect to have to replace it every few years because that's kind of a nasty world down there. But I hook my bilge pumps to it because I have to replace the bilge pumps even more often in the bilge switches. And this gives me a way to make contact quite quickly and quite easily and change out a pump or do maintenance on a pump. So I like terminal strips. Another advantage to using these removable connections for things that need to be removed over their life is the alternative. Using a butt connector means you're going to have to cut the wire, cut off the butt connector, and reconnect shorter. With these, you're not wasting wire. Eventually, the other way, you're going to either have to splice in some more wire, which is another butt connector. Remember, every connector is a resistance point, or you're going to have to replace the whole wire. So these can save you some effort, but also save you some money. What if you want to do a really big connection for something that's going to carry a lot of power? Well, these little terminals that are made out of copper, small enough that you can crush them with one hand, they're not up to it. You want something like this. This is, what is that? This is 2-gauge wire. But what I'm going to show you works with all of the bigger wires. There are these terminals that are made out of pretty heavy copper. They're tin plated so they don't corrode up too bad. And you do much the same thing. You strip the wire back, you put it in the terminal, and you need to crimp it. Well, they make tools. They make tools that are great big handle tools, and they cost a fair amount. And they do a wonderful job. But they cost a fair amount, and more importantly, you got to store them. And battery terminals are something you want to be able to do on your boat, but you don't want to do it every day. So I use this. Now, I love this little tool. In fact, I just found out you can't buy this particular one anymore, so I'm not going to loan it to anybody anymore because it suddenly became too precious. But I found other ones that look just as good, and they work basically the same way. And honestly, they're even smaller. What I like about this one is it works very well and it doesn't take up much room in my kit. All you do is you place the terminal on the wire, you place that in the appropriate slot, and you want to drive that little pin right down into the copper and it'll bring everything together. How do you drive that down? With a BFH. You give that a whack. Okay, Emily kill me if I did it on the dining room table. So I did some for a friend just yesterday, so I took some footage of it outside. Anyway, you give that a good solid whack, and that drives that pin and bends the copper and deforms it all right into one thing. It's almost like cold welding it. And they make a very, very good connection. That connection has to be physically good. It needs to be good for this reason. If this came apart, let's say this is going to your battery and this was hooked to your alternator, and this came apart while the engine was vibrating and running. Well, that would hit the engine. Now you've got the batteries directly connected to the engine, which of course has got a great big ground wire going to it. That's a bad day. Hopefully you have a fuse in that system, but at the very least, you've suddenly disconnected your alternator, so its diodes are just destroyed because you can't do that. And you've got the potential of a hot wire bouncing around. So you need to have a good physical connection. Now, you might say, yeah, sure, that looks like a good idea, but, you know, I solder mine, and that's way better. It isn't. I soldered all mine first thinking I was doing a better job. And honestly, I was lying in bed one night and I suddenly realized, oh my God, I've done the stupidest thing. The next day I bought this very tool. You can use the tool and solder them afterwards because that will kind of seal up everything and keep the corrosion from happening and lower the resistance. And it's a wonderful idea, but you need the physical connection. And here's why. If you have this on a terminal, and the terminal has bad connection or develops a bad connection over time, you'll get resistance. We got Ohm's law, right? V equals IR. So we're going to do a little algebra in a second. But remember, when you have something like V equals IR, you can just shove I times R where there's a V in another equation. Well, we have watts equals volts times amps. So P equals VR. If we shove the other term into that equation and simplify it just a tad, we get power, watts, equals I squared R. So if we had 1 ohm of resistance and we ran 50 amps through it, we have 50 squared times 1. So that's 2,500 watts being generated right there. This is copper, it conducts heat really, really well. Well, that copper will get super hot. And the super hot will melt the solder, and you don't have a physical connection once the solder is melted. And melted solder is just like water. Bang, same thing. So always, always, always make a good, strong physical connection. And then add the solder if you want to. It may be necessary for your peace of mind. It's probably a good idea, but honestly, I don't find it terribly necessary. Why don't I find it necessary? Because there's other lotions and potions you can use. Now, I'm going to show you some things I use, but first I'm going to talk about what is commonly used. So by lotions and potions, I mean goos that you put in to protect this connection. You're protecting it from corrosion. Remember, corrosion is our enemy, but some of these goos have an other feature or two. What you're going to find a lot of people recommend, it's kind of the official thing to use, is called dielectric grease. It's also called tune-up grease. And what it is it's a grease. Greases are great. They do all kinds of stuff. It's not just for lubrication. They keep oxygen away. It's like a little wall all over things. Dielectric grease is grease that will not conduct electricity. Now, if you've got a little connector with a lot of pins close together and you want to protect it from oxidation, use dielectric grease. Because if you use the things I use, you're going to get arcing across between them. Why do I say that? Well, because I use conductive greases. There are some conductive greases available that are just for this idea. This one has zinc and carbon in it, both conductive. This one is actually an anti-seize that you would use to keep mechanical fasteners from galling, but it's grease with copper in it, and I use that. The downside of these things is virtually everything that you would use to make them conductive makes them dark and messy. So if you're going to be like near some upholstery, you don't want to use this approach. But, you know, for something in your bilge or something, these are a great idea. So all you do is you put some of that on the, whether it's dielectric or conductive, you put some of that on the wire before you put the terminal together, and then you make the terminal. And I mean that both for the big ones and for the small ones. You might think, well, dielectric grease, that's non-conductive. I won't get a good, nah. When you hit that thing with a hammer or crush it with this device, the metal is touching the metal in a very serious way. It pushes the grease out of the way where the contact is. The grease is just in all the other places where oxidation would happen. Now, another thing I use with great effect, and I honestly use this a lot, especially outside, is regular silicone, just RTV silicone. I keep a small tube of it right in my electrical area. You know, we have big tubes of it and caulking tubes of various different things like that for more boat maintenance deals, but I always keep a little tube that I can seal up nicely with my electrical stuff. And I often put some inside the connector and crush it in there. It kind of works like the shrink connector, the heat shrink connector, except If you don't have a heat shrink connector, it works for the regular plastic style. So another lotion and potion in my book, that's a good idea. That reminds me though, let's say you wanted to, for example, on this one I overstripped it a tad, so I've got some exposed copper, and maybe it doesn't look as nice as you would like it to look. Or maybe you'd like to try to keep the moisture from getting in there a little bit. You never really will because these things are open on the end. Well, there's this stuff. This is heat shrink tubing. It's much the same as what that other connector was made out of. And if you put that on and then put this together using whatever lotion or potion you want, give that a whack with the hammer, make it a good physical connection like I showed in the side video. Clean it up. I put this on so many times I've made a mess of it. These little wires shouldn't be allowed to hang out like this, but I'm just faking it this time, right? Solder it if you want to, but when you're all done, bring the heat shrink tubing up, put it over both, give it your heat source. I'll use my handy little dealie again. And that will shrink down and make a tight fit and look quite professional, if I do say so myself. So now it has a protection. I use this for protection, but honestly, I also use it to label my wires. So if I had two hot wires coming into an area and I had to pull them through a wall, if I marked both ends of one of them with yellow heat shrink and the other one with red heat shrink, it's very easy for me to later on, 2 years later, saying, oh, that's the one that goes to the battery and that red one goes to the inverter, or however I would do it in my mind. You can see, so it's good for marking. We also have the good old-fashioned tape. This is regular electrical tape, vinyl tape. You can wrap that around. I'm always disappointed with vinyl tape. It wraps around and it looks really good when you've done it, but always within a couple years it's kind of coming apart and it's a gummy, sticky mess. So I've really switched to the heat shrink tubing over the electrical tape whenever I can. Sometimes you got to use the tape though, so have some around. Tapes come in various types. Like I said, this is the vinyl kind. It's good, but it's probably the worst of the three. There is something called self-amalgam tape, I believe, and that is wonderful stuff. You wrap it around, it's not sticky at all, and it kind of bonds with itself. Well, I just replaced some lifelines about 2 weeks ago, and I cut off this protection I had put on some area so that I wouldn't poke me, you know, around a cotter pin, that kind of thing. Well, it was self-amalgam tape, and I'm thinking about it. I put this on 30 years ago. It's been moving and shaking in the ocean. It's gone 20,000 miles. It's been out in the sun for 30 years, and it was still great. So I like the self-amalgam tape when you need to use it. And then there's something called friction tape. I use it, but I use it for weird things. Anyway, that's another thing. And historically, electricians would wrap something in friction tape and then cover it in vinyl tape afterwards. Up to you. Again, shrink wrap, that's the way I do it now. Okay, now we've talked about how to get a nice end on a wire that's as good as it can be resistance-wise, accepting that every time we make a change in anything, there's going to be some extra resistance. Hell, there's resistance per foot in a wire, if you remember. Now we want to connect things together. We can put them on a terminal block. We do that just by stacking them up and putting the bolt back on. You would want to put the bolt on good and tight so that it presses them together quite firmly. If you have a bad connection, you have room for oxygen to get in there, and also just plain when a contact has an elephant standing on it, it has better connection and lower resistance than when it's sort of in the area of the same place. That's not a good connection. That is a good connection. So if you're using a mechanical fastener, use the mechanical fastener. Sometimes a terminal block just doesn't work out. There's no room for it. Well, it's perfectly reasonable to use a regular mechanical fastener that's not connected to anything. You have to realize that this possibly charged copper is going to have to be protected in some way, either retained to a wall or wrapped in something. So you can put a bolt through, and you can have a whole stack of these things and put them together on a bolt. Now, this is a stainless steel bolt. This is probably the single worst metal for conducting electricity. You're really counting on the terminal to terminal connections in a stack possibly of these things. If you can swing it and you have one available, using a bronze bolt is so much better. But honestly, I looked and I didn't have any in my kit the right size, so I'm doing this with stainless steel. So do as I say, not as I do. If you make a stack of connections, you will get corrosion eventually between them. The resistance will go up little by little. You just have to accept that. We're going to eventually talk about how to use a multimeter to figure out if there's voltage drop in a circuit and where it is and find it. But just for now, you have to have good connections between these things. So if you suspect a problem, or if you're using old copper or reconnecting on, make sure it's clean. Take some sandpaper and clean both sides of all these terminals and then put them together. Don't put corroded terminals together. You will have problems. These big terminals, just like the little plastic colored ones, come in all different sizes, but since they don't have plastic, they go by actually printing on. For every wire gauge that you could possibly buy, right up to great huge ones, there are terminals. The terminals basically are qualified in two ways. You know, once we start with good tin-plated copper, we have the size of the wire and the size of the hole. It's important that the hole size be more or less right to what you're doing. Obviously, it has to be at least big enough. Drilling one of these out later is a pain in the butt. I always carry 3/8 and I carry some other sizes too. But I use 3/8 to connect things together as my biggest size. And I find it ample for anything. Let me show you one other special purpose terminal. I don't think this one's for everybody. I've been working with that bank manager and I had to put a lot of things in terminal blocks. Oh, here's a motherboard for a bank manager. We have this terminal block. You'll see these, your autopilot will have these, lots of things on your boat, lots of equipment. You've got a little screw terminal and you open it up and then you put the wire in the slot and you screw it down. Well, if you put the wire in the slot and you have like one little hair of wire sticking out, these are all really close together and they tend to short out, and sometimes that can be detrimental. Also, these screw terminals, they're wonderful things and they're great for solid core wire. But if you put the stranded wire that you're using on a boat in them, they might be tight at first, but with some vibration, all the wires kind of shift around and then it's not tight anymore. And if these aren't tight, they don't make a good contact. So these things are made. These are called ferrules. It's a way of taking stranded wire and bringing it together into a good hard kind of a ending that is really good for these terminal blocks. What you do is put it over the wire, again colored for the different size wires you would want. Grab its very special tool, which is actually kind of neat. It just squeezes down from all directions into a square. Put the ferrule in and just go squeeze, squeeze. Now you've got this nice, square, hard, easy to clamp onto end that has no little possibility of wires going in all directions. Now, 20 years ago, this is a very special tool that nobody would really get because it would probably cost a whole bunch of money. But now on Amazon, I think I paid like 20 bucks for all of these and this, and it's almost a lifetime supply. So, ferrules. One more way to end a wire. So that brings an end to terminals. Thanks for watching. I hope you found this useful. Stay tuned for other videos in the series, and bye from Temptress.